Today's lesson, lesson 3 on rotations, is our third lesson in our unit on transformations. And our essential question stays the same. How can you best show or describe a change in position of a figure? So let's see what we have in store today. So our goals for today's lesson are to learn how to rotate a figure around a point, to learn how to rotate a figure around the origin, and to take notes that will help us learn and study 8th grade math concepts. So since this is our first video, I wanted to point out a few things to you. If you ever see this pencil picture, that's something you for sure are going to need to write down. When you're seeing the eyeball picture, it's something that I want you to watch first and then add examples as we go through the video to help yourself better understand. All right, for today's lesson, we have 2 vocabulary words. The first one is rotation. Rotation is a transformation in which a figure is turned around a fixed point, and it does not change the size or the shape of the figure. We're literally just taking the figure itself and turning it in a circle, however many degrees that the problem tells us we need to turn it. There's 2 different ways that we can turn a figure. We can turn clockwise, starting at the very top and moving to the right, all the way around in a circle, or counterclockwise, starting at the very top and moving to the left, all the way around in a circle, 360 degrees. Our second vocabulary word for today is the center of rotation, or a fixed point around which shapes move in a circular motion to a new position. So I'm using this snowflake as an example. So my center of rotation, if I started turning this snowflake around and pretending that I had a screw or something right in the middle of this snowflake holding it in place but still allowing it to turn, that center point would be the center of rotation. It's what I'm turning my snowflake around. So now that we know our vocab, let's see what today's lesson has in store for us. All right, so let's take a look at what it looks like to rotate a figure around a point. Here I have my rectangle ABCD graphed already on my coordinate plane. The question is asking me to graph the figure and its image after a clockwise rotation of 90 degrees about vertex C. Then give the coordinates of the vertices of rectangle ABCD. And again, those little dashes after mean the image. So here on the coordinate plane is the pre-image, and we're looking to see what the image is after, what the vertices are. So it says I want to rotate 90 degrees around vertex C. Vertex C is special then. That means I am not changing my point C. That is going to stay the same. What I'm going to do with the rest of my figure is rotate it clockwise. So I'm going to take each one of these points and move them, swinging them 90 degrees in the clockwise direction. So what I want you to take a look at is the side BC here. Right now, my side BC is horizontal on my coordinate grid. If I shift it 90 degrees, it means it's going to be vertical. So all I'm going to do is take my point and rotate it up 90 degrees, forming a new angle, and making sure that I stay the same distance in between my point C and point B. So here I've got 1, 2, 3, 4, 5 units. So I need to make sure that I'm 5 units up from C here. 1, 2, 3, 4, 5. And I'm good. So I'm going to put my new point B right up here. Now I'm going to follow through and do the same thing with point D and A. So I'm going to start from D here, and I'm going to move 90 degrees in the clockwise direction. So again, my side DE was going vertically here, and I needed to move it 90 degrees so it becomes horizontal, 3 units away from C. Here's my new point D. Last but not least, I'm going to add point A in. So I'm going to start at point A, again rotate 90 degrees, and I'm going to add my last point A. So here is my new rectangle. I'm going to go over that in green so we can all see it. With points A, B, C, D, or my image. So now to finish the question, it asks me to write the coordinates for each of my vertices. So again, C should be pretty simple because it's going to be the exact same thing since that's what I was rotating around. So my C still stays -2, 1. D right here is at 1, 1. So then A is at 1, 6, and B is at -2, 6. That is the final coordinates of all of the vertices for rectangle A, B, C, D, or the image of it, I should say. So Alright, so what we had just talked about in the last problem was rotating around a point. Another type of rotation is rotating around the origin, or the point where our x and y axis meet. That origin is always that 0, 0 marker on our coordinate plane. So something to notice when you're talking about rotating around the origin is that we have 4 quadrants, and anytime we rotate 90 degrees, we're moving our shape 1 quadrant. Anytime we're rotating 180 degrees, we're moving our shape 2 quadrants from where we originally started. So like here, I went 1, 2. And then 270, we're moving 3 quadrants. 1, 2, 3. But what's really important to note, and what we're going to talk about in our examples, are these symbols down here. This, again, is the algebraic way of showing what's happening as we're rotating around the origin. So what these are saying is that when I'm given a point, x, y, for this first one, and I'm rotating 90 degrees, what I'm going to do is I'm actually going to take whatever my number was for y and put it in the x coordinate of my new figure. So, for instance, if I would have 3, 4 as my point, what I would do then, if I'm rotating 90 degrees, is my y, so my 4 would become my new x. And then my x coordinate that I had before would become my new y, and I would make it negative. All this is really doing is saying I'm taking my original point and I'm flipping it into the next quadrant over, which is going to change my coordinates like this. So we'll talk more about that in our example problems. again, referring back to my notes. All right, so our last problem for the day is we're going to rotate this quadrilateral, MNPQ, around the origin counterclockwise 270 degrees. So that will be like taking this point and moving 90, 180, 270. So we're moving it 3 quadrants. Moving 270 degrees counterclockwise is the same thing actually as moving 90 degrees clockwise. So you can do this 2 ways. You can shift your shape around all 3 coordinates, or all 3 quadrants, 270 degrees, or you can recognize if I move this shape 90 degrees clockwise, it's the same thing. So if I'm moving my shape clockwise, I'm going to see that my rule for this is that I'm switching my X and my Y, and then my X is going to be negative. So, in my new rule, so what that looks like is my point Q is 2, 1. So my new point Q of my image, after rotating again at 270 degrees or 90 degrees clockwise, I am going to have 1, negative 2. So my new point is going to be at 1, negative 2 right here. Now I can tell that that is in the right place by doing a quick check. I can take my Q point right here and draw a 90-degree angle through the origin, through 0, 0, and hit that point. That's how I know that I'm in the right spot. We're going to be going over more examples like this in class, but getting this example down in the first place is a good place to start. So continue on with all of the points. For point M, which is 2, 5, it's going to turn into 5, negative 2. P, which is 6, 1, is going to turn into 1, negative 6. And last but not least, N is going to be, start at 6, 4, and it's going to turn into 4, negative 6. So I'm going to graph these last points so I can have my image. So again, my image of M is going to be at 5, 1, 2, 3, 4, 5, negative 2, my N is going to be at 4, negative 6. 1, 2, 3, 4, 5, 6. And my P is at 1, negative 6. So this is my quadrilateral rotated 90, 180, 270 around my origin. Here's a little joke for you to end our video today. What do you get when you play tug-of-war with a pig? Bring your best guess to class.